Dear students, today we are going to study about enthalpies, different types of enthalpies, okay? And for explaining you all these different types of enthalpies, I have used the cycle of Born-Haber's process cycle, okay? Or Born-Haber's cycle, okay? In this, okay, we are taking what? Sodium in solid state, okay? And half Cl2 in gaseous state. This is must, okay, in which state the element is, okay. So here we will be using what? The enthalpy of formation, which is represented by delta FH, okay. What is this enthalpy of formation? Actually, enthalpy of formation in this, what we are doing, we will be making 1 mole of a stable compound in its stable state, okay. So here this Na, which is in solid state, and Cl2, which is in gaseous state, by using enthalpy of formation to form the most stable state of NaCl, which is in solid state, okay. Now here we had used enthalpy of formation and directly we have made what? NaCl, which is in solid state and which is in the most stable state, okay. But there can be a series of reactions which we can take over in order to form this NaCl, okay. So let us study those series and understanding the different enthalpies which are being used, okay. So here you can see here Na in solid state and half Cl2 in gaseous state. We are using here what? Standard enthalpy of sublimation, okay. So when we are saying standard enthalpy of sublimation, you all know what is sublimation? Directly changing from solid to gaseous state. So here the enthalpy of that sublimation, that is delta SUBH, and here we have used this sign which denotes that it is in the standard form, okay. So here the solid, here Na, which is in the solid state, is now being changed into Na into the gaseous state, and so here we are using what? Enthalpy of sublimation, okay. So now we are getting what? Na in the gaseous state plus half Cl2, which is in the gaseous state itself only from before. And here yes, you can write down the energies which are being used. Like here it has been used 1084 kilojoules per mole, okay. And these energy values, yes, you have to learn it, or it is not so essential to write, okay. Now here Na in the gaseous form plus half Cl2 in the gaseous form. Now what we are going to do, we are converting it into the ion form. So which type of enthalpy will be used? It will be the ionization enthalpy, because what we are doing, we are converting it into an ion form which is in the gaseous form. So now you can see here sodium is being converted into Na plus. Here 1 electron has been removed out. Okay, so Na plus half Cl2 in the gaseous form. Now, naturally you have got what? Na in the gaseous form plus half Cl2. Don't get afraid with this half numbers, okay beta? Everywhere. It is not so complicated, okay? Just in a simple manner, instead of writing Cl, we are what we are writing? We are writing half Cl2. So, naturally, if we are writing half Cl2, here, this bond has to be broken in order to get Cl, isn't it? If I am saying half Cl2, it is Cl, isn't it? So what now? Which type of enthalpy will be used? It will be the bond enthalpy, okay. So bond enthalpy is what? It is just the energy required to break the bond, isn't it? So here what happens, this bond enthalpy, here I said to you, no need to remember all the values, but yes, in order to understand, I am explaining you all. If it is half Cl2, okay, the bond is breaking, this Cl2 will be breaking into what? If 1 mole of Cl2 is there, it will be breaking into 2 Cl atoms, isn't it? And naturally the energy which will be if you are breaking any bond, what will happen? You will be requiring the energy, no? So here the energy which was required was 242 kilojoules per mole, okay. So now if it is Cl2, the energy which is what it is? 242 kilojoules per mole. But when we are talking about only half Cl2. So you can just make this value half and it will come 121 kilojoule per mole. So now naturally what happened over here, this half Cl2 we have used the bond enthalpy, it has been used over here. Naturally it is converting into one atom of Cl. Okay, so now we are getting Na plus Cl in gaseous form. Okay, now we have got this Na plus Cl. Now we have to convert this also in what? In the negative form. Then only they will combine and they will form NaCl, isn't it? So what energy is required over there? That is the electron gain enthalpy. Okay, so in this, what is this? Using this electron gain enthalpy, we have studied in the third chapter of the chemistry. What is electron gain enthalpy? Do you remember? Okay, now here this electron gain enthalpy is used. Okay, and naturally this chlorine, which is in the atomic form, is being changed into what? The negative form or in the anionic form. Okay, and naturally when it is changed into the anionic form, these two are being what? Combined to form what? The NaCl in solid form. But yes, when it is being formed, naturally what will happen? The energy will be released out, isn't it? Yes. So what is this lattice enthalpy then? Lattice enthalpy is what? When one mole of ionic compound dissociates into ions and gaseous state. Okay. So what is this? In this, in lattice enthalpy, it explains what? If NaCl is present in solid state, it will be breaking up into the corresponding anions and cations. Okay, so here the thing will be only when any compound is breaking, what will happen? Energy is needed, and when anything is being formed, what will happen? Energy is evolved. Okay, so here if it is breaking, naturally it will be in the positive form. Okay, so here if we are calculating, okay, this whole process, here we have directly made NaCl in this using what? Enthalpy of formation, which said that what? Yes, Na plus half Cl2 had formed this. Okay, but when you see the whole process over here, here also this much energy will only come. So if we want to calculate the lattice enthalpy, it becomes difficult to calculate. Okay, it is not so easy. But yes, if we are calculating this enthalpy of sublimation, the bond enthalpy, the ionization enthalpy, the electron gain enthalpy, these all are easy to calculate. But directly to calculate lattice enthalpy is very difficult. So we have to, in order to calculate all the different, this lattice enthalpy, we have to use all these different enthalpies in order to get that lattice enthalpy. Okay, so to understand the different enthalpies, okay, now I hope so you would have understood what is this bond enthalpy, ionization enthalpy, electron gain enthalpy, enthalpy of sublimation. Okay, now let us study about some other enthalpies also, that is the enthalpy of solution and enthalpy of hydration. Actually, suppose we have taken any substance which is in solid state, okay, you are going to change it into the gaseous state. Which enthalpy we will be using? We will be using what? Enthalpy of this lattice enthalpy, isn't it? We have studied right now. Okay, so in order to convert it into gaseous form, we are using what? Lattice enthalpy. But if we want to change this solid into what? Liquid form, okay, or the aqueous form, which enthalpy we will be using? We will be using what? Enthalpy of solution. Which enthalpy will be there? Enthalpy of solution. And yes, if we are converting this gaseous form, okay, into what? The aqueous form or the liquid form, the enthalpy will be what? The enthalpy of hydration. Okay, so you just remember, converting a solid into the aqueous form, enthalpy of solution; converting the gaseous form into the aqueous or the liquid form, enthalpy of hydration. Let us study enthalpy of reaction. Okay, enthalpy of reaction is what the energy released or it is being used up during the reaction, the enthalpy which is taking place during the reaction. Okay, so in this we will be studying Hess's law of constant heat summation. Actually, here if in a reaction, how much energy is being released out, okay, or it is being absorbed, it can't be made out. But yes, if the intermediate steps are taken into account, we can calculate or we can sum up what the energy which is being released out in the reactions. Okay, so here I'll take an example. Carbon in the graphite form plus half O2, okay, it forms carbon monoxide. Here enthalpy of reaction we are not knowing. Okay, but yes, if we are taking the intermediate step like carbon in the graphite form plus oxygen, it gives carbon dioxide, and here we are getting the enthalpy of reaction, that is minus 393.5 kilojoule per mole. Okay, second intermediate step, see carbon monoxide plus half O2, we are getting CO2. Here also we are getting the enthalpy of reaction, that is minus 283 kilojoule per mole. Okay, now the third intermediate step, carbon dioxide. Okay, here it is breaking into what? Carbon monoxide plus half O2, and here so the energy it is required, so here enthalpy of reaction becomes plus 238.0 kilojoules per mole. Okay, when we are seeing these intermediate steps, okay, when we sum up what this reaction number 1 or the step number 1 and step number 3, okay, so when we are doing that, yes, this carbon dioxide, if you take it at that side, it becomes minus, so it becomes cancelled. Okay, here this half O2, if we are taking out this side, naturally it becomes now only half O2 will be present over here. Okay, so here carbon plus half O2, it is giving what? Carbon monoxide, which is the main reaction over here. Okay, so here when we sum up this 1 and 3, what happens, it is what we will be getting, the enthalpy of reaction is minus 393.5 kilojoule. Okay, and the third one is how much? Plus 238. When we sum up, we get the value minus 110.5 kilojoule per mole. Okay, which is the answer over here, that it is minus 110.5 kilojoule per mole. Okay, so by the intermediate steps, this energy of this reaction can be calculated, and this is what Hess's law of constant heat summation. Okay, so this is all for today. Good day, take care.